Hello, everybody. Hope you are having a great Wednesday, and we are ready to get started with day 3 of our 2026 HURREVAC training webinar series on storm surge and flooding hazards. My name is John Boyer. I work at Sea Island Software. We're the team that helps with HURREVAC's operations and maintenance and development and support and training. And I'm very excited today to be able to bring you 3 expert presenters to walk us through all of these concepts that we're going to hear about today, starting with Cassandra Mora, Storm Surge Specialist at the National Hurricane Center, followed by Dr. Owen Shea, Warning Coordination Meteorologist at NOAA's Weather Prediction Center. And we're also happy to be joined by Jason Elliott from NOAA's National Water Center, the Service Coordination Hydrologist. And we're going to start with a presentation from Cassandra.
Hi, everybody. My name is Cassandra Moore. I'm one of the storm surge specialists here at the National Hurricane Center, taking a break from storm surge operations for Tropical Storm Arthur that's in the Gulf right now. The storm surge unit at the National Hurricane Center has 4 members. There's me, Laura Laka, who's also in the room, Heather Nepal, and our storm surge team lead, Cody Fritz. So we're a group of 4, very small, but we work round the clock when there's a storm making landfall. So if you ever come across these names, that's one of us in the storm surge unit. All right, so today I'm going to talk to you guys about how we communicate the danger of storm surge caused by tropical cyclones. We're going to demonstrate how probabilistic storm surge forecasting provides a more complete picture of risk and impacts, and highlight the products available for planning and response to storm surge that are within HURREVAC. So just a brief introduction here to our storm surge mission. We're here to serve the nation's growing need for storm surge information by providing accurate real-time storm surge forecasts during tropical cyclone events like today, supporting coastal community preparedness and resiliency through storm surge vulnerability mapping, and increasing awareness through outreach and education. And here's just some examples of us doing that. On the top there is our director briefing one of our storm surge products, our peak storm surge graphic. In the middle is an example of one of our storm surge risk maps. And on the bottom is an example of Laura and Heather teaching one of the FEMA courses where we go through an exercise where the participants get to build a storm and see what the storm surge flooding footprint ends up looking like. So we're going to go through all these products today, but let's just start off with why it's so important that we have a unit at the Hurricane Center dedicated to forecasting storm surge, and why storm surge has its own products separate from other tropical cyclone products. And that's because for a long period of time and for all of history, storm surge has been the leading cause of death in the United States. This study shown in this pie chart here from 1963 to 2012 shows that storm surge has caused almost 50% of the deaths, and more than 80% of the deaths have been due to water. So that's not to exclude the deaths that also happen from freshwater flooding. Just the overall message is that water is the big killer. If you ever heard, we hide from the wind, run from the water, it's because wind causes less than 10% of the deaths. If you've heard in recent years that freshwater flooding has taken the lead in the direct fatalities related to tropical cyclones, that has been true up until 2022, shown by this pie chart here. But then we had Hurricane Ian in 2022. So Hurricane Ian made landfall in an extremely vulnerable and populated coast in the Fort Myers area there. And we can see that storm surge here was the leading cause of fatalities from Hurricane Ian. So what we're taking away from this is there's still a lot of work to be done when it comes to storm surge risk communication. People still have a long way to go in terms of understanding the hazard, and we have a long way to go in terms of figuring out a way to better communicate the hazard of storm surge. So just some definitions here. Storm surge is defined as the abnormal rise of water generated by a storm over and above the predicted astronomical tide. And in that example there on the right, you can see that above the normal tide level, above that mean sea level, or above normal tide level, you have the 15 feet of storm surge. The technical definition, storm tide, is the water level due to the combination of storm surge and tide. So you can see at high tide is 2 feet, so storm tide there is 17 feet. And then inundation is the flooding of normally dry land resulting from storm tide and other factors such as waves. So at the house, that might be 2 to 3 feet of storm surge above normally dry ground. But to eliminate confusion, we're usually using the term storm surge, and we'll reference it at above ground level. So there's a lot of things that go into forecasting storm surge. There's a lot of factors that a storm has that can change the amount of storm surge you get or where that storm surge is. I'll run through each of one of these quickly. So there's a storm's intensity. A stronger storm can produce more storm surge. The size of the storm, your radius of maximum wind, a larger storm is going to produce more storm surge than a smaller storm. If you look at the comparison of Hurricane Charlie in 2004, which is a very small Cat 4, versus Hurricane Ian in 2022, which was a very large Cat 4, both made landfall in a very similar area, but both had very different flooding footprints. Most of that was due to the storm size. Forward speed also has an impact on the amount of storm surge you get. With a slower storm, that storm surge is going to make it farther inland. You can see on that image on the left, there's some red up in the upper right corner. That's storm surge making it farther inland into Pinellas County there. Where a faster storm, you're going to have a higher peak of storm surge at the immediate coastline, which you can see on the right image there, where there's a lot of red directly at the beach and less red inland. The width and slope of the shelf, so the ocean shelf, has a huge impact on the amount of storm surge that you can get. Taking a look at that bathymetry, or the shape of the ocean bottom image there, the Gulf is very vulnerable, has many areas that are very vulnerable to storm surge with a very slow, gradual sloping shelf. All the water is able to easily collect there. Whereas if you have a steep shelf, like in an island environment, it's hard for the wave to feel the ocean bottom, and you're not going to end up getting as much storm surge. Angle of approach that the storm has to the coastline will alter where the storm surge goes. So in this example, with a storm that's approaching the coast from the southeast direction versus more of a easterly direction there in New Jersey, is going to alter the amount of storm surge that you get in the back bays behind Staten Island and in the Raritan River there. And then the landfall location, the exact track of the storm is going to have an impact on where that storm surge ends up. And Hurricane Laura was an example of this. More recently, Hurricane Milton was an example of this. If you have a storm making landfall on the wrong side of the bay, or the right side of the bay, then you're going to get a different storm surge flooding footprint, where if you were to get the storm to, in this case for Hurricane Laura, make impact on the left side of the bay. You can see where that red really fills in all over the Lake Charles area. So just a small track shift of 10 to 20 miles can have a huge impact on exactly where the storm surge focuses. So how do we account for all of these things when making a forecast? We have all these things in the back of our mind when we're trying to come up with the peak values, exactly how far inland the storm surge will make it. The way we do this is by using a model called SLOSH. SLOSH stands for Sea, Lake, and Overland Surges from Hurricanes. It's a numerical model, and we use it to estimate storm surge for historical, hypothetical, or predicted hurricanes. And that image there on the right is showing all of the SLOSH basins that we currently have for 2025. So you can see how we have most of the United States mapped out there, and as well as many international countries. We're starting to expand to do flood inundation mapping for a storm surge. So how SLOSH works is SLOSH needs a grid. So what we were just looking at there in that image, you need to pick your basin, and then you need the storm characteristics. So a lot of those factors are going into the model. So the size, the speed, the intensity of the storm. Then we run the SLOSH model and get an output of water levels above reference level NAVD 88. And through some post-processing, we are able to forecast that storm surge water level in above ground. And it's important to note that SLOSH is a diagnostic model, and it's only as good as the wind forcing that's in the input. So it's only going to be able to simulate what the wind that we're able to put in it is. So we use SLOSH to create all of these storm surge products. So now we're going to dive into the storm surge planning and response tools that we have. We have pre-computed products using the SLOSH model called MOMS and MEOWs. So those are made ahead of time. Those are actually available right now within HURREVAC. And then we also use the model to create real-time response products. So our advisory products, one of which is out right now, that peak storm surge graphic for Tropical Storm Arthur. We'll also create storm surge watches and warnings, and we also have a potential storm surge flooding map. And we'll go over all of these in the next coming slides. So let's start off with our pre-computed products. The first one we'll talk about here is the MEOW. Yes, these have kind of funny names. There's the MEOW and there's the MOM. So the MEOW stands for the maximum envelope of water. And how we get this product is by running thousands of hypothetical storms through SLOSH for a basin that we pick. And we're going to take the composite of the maximum storm surge from a specific storm scenario given a set of parameters that you can choose. And the guidance that comes out of the MEOW is used for planning and operations before real-time guidance is available. So in that graphic on the bottom, this is how the MEOW works. You're going to choose, the user can choose the storm category, forward speed, direction, the tide anomaly, and the basin. And then what's built in is all possible storm sizes and landfall locations. And if you're a visual learner, here's an example of how a MEOW is made. So in this example, the user selects a category 3 storm, landfall direction to the west-northwest, forward speed of 15 miles per hour, and the initial high tide. So this is if you're trying to come up with a plan, you're days out from a storm making landfall, there's no real-time storm surge guidance yet, but you want to know how vulnerable your area is to storm surge. That's when you would maybe use this MEOW. So looking at the northern South Carolina and southern North Carolina coast here, what the MEOW does is it's going to vary all the storm tracks and come up with a composite of storm surge. And in that pixel that's highlighted right there, through all of the storm tracks, the highest value of storm surge that you can get with all of those user selected parameters is 13.8 feet. So again, these are useful for when we don't have real-time guidance yet, and these are available within HURREVAC. You can select multiple directions of storm at once if we don't know exactly what direction the storm might be coming from. And they will blend, and again, you get the composite value of storm surge modeled there. Moving on to the other storm surge pre-computed product from SLOSH called the MOM, which stands for the maximum of the MEOW. Sorry, not maximum of maximum. So this is a collection of all of the MEOWs. So what the MOM is going to show you is the worst case scenario for a storm surge at any location for any particular storm of a single category. So it's a composite of all the data. The user just chooses the category. It's going to vary all of the hypothetical storms, forward speeds, angles of approach, size, initial tide, and landfall location. And these are used to create our storm surge risk maps, which are available on our National Hurricane Center website, as well as within HURREVAC. They are high resolution inundation maps for effective risk communication and analysis. And these can be used at any time in the off season, well before a storm. They're used for planning, tools to evaluate risks of critical facilities is one example of one way to use these MOMs. This is an example of how running a MOM works. So the user is going to select the category, and then what you will see is a composite storm surge value of all possible storm directions, sizes, intensities, speeds, etc. And it's important to note that no single hurricane will produce the regional flooding depicted in one of these MOMs. It's just showing the maximum vulnerability snapshot to storm surge that you possibly could experience at that area. So again, really good for planning. These are used for creating evacuation zones and evacuation study planning. And this is how you can view them within HURREVAC. And there's where you can select the single category of storm, and then you update the map and they will pop up within your HURREVAC window. So now moving on to our real-time products. So those moms and meows, again, are pre-computed. You can access them at any time within HURREVAC. However, the next products that we're going to discuss are only available when there's a landfalling storm. So when we have a storm making landfall, we're going to do some real-time storm surge modeling using SLOSH, using an ensemble version of SLOSH called P-Surge, which stands for Probabilistic Storm Surge. This is the statistical dynamic forecast system using SLOSH. The probabilities are based on the National Hurricane Center official forecast and 5-year errors in the official forecast. So what's important about that bullet is that we are going off of the hurricane specialist forecast for this ensemble. It's going to account for uncertainty in storm size, cross track, so that's your landfall location, the along track or the forward speed, the intensity, so it's accounting for stronger and weaker storms, all based off of the official National Hurricane Center hurricane specialist forecast. So here's an example here of how the P-Surge was able to help us forecast storm surge risk from Hurricane Ian days in advance. This is at, I think, around the 72-hour before Hurricane Ian made landfall. The Hurricane Center official forecast at the time, there was a lot of uncertainty. It was forecast to enter the Big Bend region of Florida, but the P-Surge ensemble was able to vary the crosstrack and was able to help us evaluate the risk of storm surge in Fort Myers 72 hours before the storm made landfall. And you can see the red line there is where Hurricane Ian actually ended up going. So another important thing to note is why we use probabilistic forecasting versus deterministic forecasting. As we just talked about, this is the same example with Hurricane Ian. The probabilistic guidance that's giving us that reasonable worst case scenario is going to cover the risk better than just using a single deterministic track. However, we are able to go in and evaluate the deterministic track solutions to see what the maximum vulnerability is given a certain track or size or intensity, speed of storm. So we do have that ability to look in depth using our internal model guidance. But in order to account for all risk, and Ian was a great example of this, we are going to want to use the probabilistic guidance, which is why that is what you see in the storm surge products and what you see when it comes in P-Surge data. So now on to our first storm surge product. So P-Surge, again, is the model that we're running. And then you're able to see that P-Surge data in our potential storm surge flooding map. So this map, again, is showing you straight model output. It's not a flooding footprint. It is showing you that reasonable worst case scenario. So anywhere that you drop a point on this map, any location is going to show you a 1 in 10 chance of that water level being exceeded. So the 90th percentile of storm surge. So again, this inundation map is showing the height above ground that water could reach, re-emphasizing this is the reasonable worst case scenario. And this can be issued up to 72 hours prior to the onset of the hazard. We have that ability now. This is, again, running off of the official National Hurricane Center forecast. So it will be released about an hour to an hour and a half after the official National Hurricane Center advisory is released. That's just because it needs to process, and then we need to run it again to make sure that the water levels are being displayed in that above ground level. So again, an hour to an hour and a half after the official products come out. And then this is just an example of how to look at the potential storm surge flooding map within HURREVAC. You can click on that wave there, and then it will display the P-Surge data or the 10% exceedance data. You have the ability to change the opacity, change the base maps if you would like to see imagery. And again, this is model guidance. This is not a flooding footprint. You are able to turn on the intertidal zones as well. So that's land that's already wet. and it will overlay on top of the P-Surge data. Okay, on to our next product. So using all that real-time model guidance, we're able to make the next two, they help us make the next two products. So this is the Storm Surge Watch and Warning. The Storm Surge Watch is typically what you will see first when there's a possibility of life-threatening inundation within the next 48 hours. It will be in the light purple color. And then the Storm Surge Warning is the danger of life-threatening inundation, generally within 36 hours. And the Storm Surge Warning will set off a WIA alert on your phone. So the purpose of having the Storm Surge Watch and Warning, these really don't show any detail about the number of storm surge that you're going to get. That's because we don't want people to worry about that detail. We want people to understand if they're in an area that has the risk of experiencing life-threatening storm surge. So this is a product we don't take lightly when we release it. This is something that we're only going to issue when there is a chance of that life-threatening storm surge inundation. And this is meant for the general public as well as decision makers to really help aid in those evacuation decisions. And you can see an example here of our deputy director highlighting a coastline that's vulnerable to life-threatening storm surge during the live stream using the storm surge warning. And this is another product you're able to look at within HURREVAC. And here's an example of how to access that by clicking on the double red flag. You also see the wind watches and warnings are listed there. Storm surge is separate from the wind watches and warnings. It's its own hazard. And then finally, we have the peak storm surge forecast graphic. So this graphic is used to show our forecast for the peak inundation along the immediate coast from storm surge and tide within the next 48 hours. So this is showing the height that water could reach above normally dry ground occurring somewhere within those 2 points. It's not location specific. We're just showing that somewhere within those 2 points, this is the peak storm surge that we're expecting to see. And again, remember, this includes tide. No need to add or subtract tide to this graphic. And this is introduced when the watch or warning is in effect. And this might differ from the potential storm surge flooding map because this has the forecaster added value to it. We might be seeing something that maybe the model isn't capturing at that time. But we are using that guidance to help us create this graphic. And there is an example of me briefing the graphic to the Coast Guard. This is really helpful for briefing state decision makers down to local decision makers. And then here's an example of how to access this graphic within HURREVAC as well. You're able to turn on just the colors as well as the communication points that we use. And just to reiterate, all these products, all these real-time products are within HURREVAC there on the left side bar. And anytime that there is an active system and we're issuing these products, you should be able to find them there. You can also download the KML and GIS data off of our website if you prefer to look at it that way as well. And that is all I have. Thank you so much for listening.
So for this segment of the presentation, I will be going through the tropical cyclone rainfall forecast process, as well as an overview of the products. Some of these are in HURREVAC, and so hopefully this helps everyone here kind of look under the hood a little bit in terms of what these lines and colors mean when you see them pulled up in HURREVAC. So a little bit about what we do at the Weather Prediction Center, or WPC for short. We are one of the national centers for environmental prediction. I like to think of ourselves as like a sister center of National Hurricane Center, and our focus is primarily on the heavy precipitation hazards, to include both flash flooding as well as winter weather, winter storms, and then also extreme temperatures, from heat waves to cold waves. And in this process, we're also setting the national weather story by basically doing the surface analysis charts and a lot of the weather products that are occurring behind the scenes essentially integrating the National Weather Service from the local to the national level. We also serve as the backup to the National Hurricane Center. Should self-backup roll over and they need any assistance, we do have the software capabilities here to be able to assist with tropical cyclone advisories. So without beating a dead horse here, you already heard Cassandra give a really good overview of the motivation behind why water hazards are so dangerous. You saw two different versions of the pie chart earlier. Storm surge historically has been the deadliest hazard, but rainfall is either a close second or number one, depending on which time period you pick. And so most recently, it's taken the lead in terms of the fatalities. But regardless of which one's number one or number two, the key thing is water hazards are the top killer within hurricanes. And freshwater flooding and saltwater flooding or storm surge are two different things. And so you already saw the approach to the storm surge warning system and the modeling behind it. I'm going to take you through the freshwater flooding piece, particularly with respect to flash flooding and heavy rainfall. So to paraphrase the late Dr. Charles Doswell, an almost absurdly simple concept is how he described heavy rainfall-induced flooding. In other words, it really is just a matter of where the heaviest rain falls, in other words, where it rains the hardest, and how long it rains. So the longer the period, the harder the rains, the more potential for flash flooding. So meteorologically, it really boils down to these two factors. And so when we look at the rainfall rate and try to forecast it, we're looking at things like atmospheric forcing, how much air, how quickly can air rise, and how much moisture is there. And once the air is forced upward along, say, a cold front, for example, how much instability is there for the air to want to keep rising? So basically, those factors are being considered meteorologically, and then also, what is the orientation of the storms? Are they training over each other? Meaning, is the next storm forming and then rolling over the one before it? In the case of tropical cyclones, is the storm large in size? And then also, is it moving slowly, right? These are all the things that will enhance the rainfall duration. And so the duration aspect makes it a tough forecasting challenge. And then on top of all of that, whether or not you actually get flash flooding takes into consideration not just the weather, of course, but also the soil moisture, the topography, the hydrology behind how the water drains, right? And so very quickly, this adds up into a very complex challenge. But if we were to zero in on the tropical cyclone forecasting piece specifically, we can boil it down to 8 primary factors that affect tropical cyclone rainfall. I won't go over all of these here today, but I do want to focus on a few of them that take primary consideration. Movement, for example, is one of the primary factors. A storm that just blows through quickly won't last very long. And so because of that, the flash flood risk drops. If, however, it just stalls or is quasi-stationary, as we like to sometimes call it in the field, the storm basically is just hanging out. And when that happens, the rain will keep dumping over the same areas. A larger storm, the storm size, also is a big consideration, because the larger the storm in terms of its breadth, the longer the rainfall duration. And if you add these two things together, you get a slow and large storm, then that's typically where we would see the worst case scenarios when it comes to freshwater flooding. Topography is also important, of course. We saw this in Hurricane Helene not too long ago. Southern Appalachians, you had all this moisture pushed up against the mountains, which with the enhanced lift basically caused lots of problems on the windward or upwind side of that topography. Moisture obviously is an important aspect. Without enough moisture, you won't get heavy rainfall. And instability just helps with the creation of deep thunderstorms. Typically, when we talk about all of these different factors together, we see a lot of this come into play with tropical cyclones. So let's focus on the speed factor here. This is just an illustration of that concept that the slower the storm, the longer the duration of the rainfall. And so you can have the same intensity storm, you can have the same size storm, and the winds and the structure can all be the same, but the one storm that moves slower than the other is going to be the one that gives the most rainfall. So just as sort of a rough comparison here between these two systems on the right, Belle and Irene, you'll see how both East Coast storms, the one that moves a lot slower, ended up dumping a lot more rainfall. Obviously, these are not exact comparisons, but for the most part, you can consider the fact that with a similar track, just changing the speed of it can affect the distribution of rainfall quite significantly. The size factor, of course, the larger the storm, the more rainfall over a specific location. And so this is a comparison between Imelda and Harvey. And you'll notice how, of course, in the case of Harvey, much larger system ends up causing a lot greater amounts of rainfall induced flash flooding for East Texas. So when it comes to our products, how WPC approaches this problem of rainfall is we produce one product called the Quantitative Precipitation Forecast, or the QPF. This quite literally is the deterministic forecast for how much rainfall we expect to fall. Now, just to take a step back, I know we as meteorologists often will throw deterministic and probabilistic, these two words around. For those who may not be familiar, deterministic is basically an explicit forecast for what we think will happen with the weather. It could be a rainfall forecast. It could be partly cloudy skies, right? Or basically, it's a statement of what we think. It's the expected forecast. Probabilistic is when we attach a percentage to it, right? We try to convey the uncertainty associated with a forecast. And so that's what we mean by probabilistic. So essentially, we have one of each of these types of products. The deterministic one, the one where we're actually giving you our best guess about how much rain will fall, is the QPF product. And so this is a national map on our website, which essentially gives you in inches how much rain we think will fall for every location. Now, this is 7 days of forecast precipitation. It's always available on the WPC website. And then, as I'll cover here in the next few slides, during a tropical cyclone landfall situation, we will zoom in on this graphic and prepare and basically crop it so that it's centered on the storm, and then that gets added to the NHC advisory package. A text product corresponds to this graphical product, and that's also available on our website. Now, on the probabilistic side, in addition to giving you what we think will be the expected rainfall for an area, we also produce a product called the Excessive Rainfall Outlook, or ERO for short. So this is an outlook product that is routinely produced out to 5 days. And we basically categorize the risk of flash flooding using 4 categories: marginal, slight, moderate, and high risk. And each of these risk categories is tagged to a probability. You'll notice here in the bottom left, high risk would be at least 70%, moderate is 40%, slight is 15%, and these percentages are defined according to what are called neighborhood probabilities. It's the risk of rainfall exceeding flash flood guidance within 25 miles of a point. Now, what we mean by flash flood guidance is it's a whole separate other field, basically to say that what is the likelihood of this amount of rainfall causing flash flooding, and that likelihood will change depending on how much rain has already fallen for a particular area. So an area with wetter soil moisture, for example, would have a lower flash flood guidance, meaning it's not going to take as much rain for flash flooding to occur, right? So removing all the jargon, essentially the 4 categories here depict the flash flood potential in probabilities for occurrence within 25 miles of a point. Now, high risks are quite rare, but when they do occur, they account for basically a third of all flood-related fatalities. You see that in the pie chart in the bottom right. And when it comes to damage, they're the vast majority of flood-related damages. And so high risks are a big deal. And because of that, we also ensure that we don't get too trigger happy with high risks, right? So that you typically will only see a few of these throughout the year. These are issued regardless of whether or not there's a tropical cyclone, but when there is a tropical cyclone, just like with QPFs, we will crop down this image from our usual national chart down to a storm-centered one, and that becomes part of the NHC forecast advisory package. All right, so in terms of how to interpret this within 25 miles of a point neighborhood probability concept, the best rule of thumb is to just think of the city of Houston. It's a pretty sprawling metropolis, and it's basically a 25-mile range ring that covers the metro area. And so the best way to think about it is when you see a moderate risk issued, it's basically to say that there's at least a 40% chance of flash flooding happening somewhere within that range ring. All right, so if you were to just, wherever you are in the country, if you were to just anchor this as like your mental way of wrapping your head around this product, then you can't go wrong. So when you interpret this product, think of it in terms of these neighborhood probabilities. And as the flash flood threat progresses, we will update this product accordingly. It's updated more frequently during day 1, but then it basically has 1 day each day out to day 5. Today is a good example. We have moderate risk out ahead of Tropical Storm Arthur, extending from Louisiana, Mississippi to Alabama. And we also have a separate moderate risk area across central Illinois. All right, so I mentioned earlier that we integrate this with NHC advisories. And so this is a very, very strong collaboration that we have between these two national centers. We produce, within the NHC key messages product, we actually write the rainfall statement. And this is something we do in collaboration with the hurricane specialist on duty. And so we would go back and forth, wordsmith every single word to make sure that we're properly capturing the risk for flash flooding associated with this storm for that time. And then likewise, you see to the right in blue, the rainfall forecast. It's basically our QPF, our deterministic QPF product, drop down and storm centered. And then, or not necessarily storm centered, but centered on the threat area. And then the flash flood potential is basically our ERO product, also crops down. So this will always be available on the NHC website, part of the advisory package. I do also want to highlight 2 separate products that build upon this. And I want to highlight these specifically because not only are they available on our website, but they're also available on HURREVAC. So we have a part of our website called the Extreme Precipitation Monitor. I have the direct link here on this slide. And this essentially depicts the annual recurrence interval, or ARI, and effectively answers the question, how rare is that rainfall forecast? So those of you who might, particularly on the planning side, want to think through where does this event stand in terms of annual recurrence interval? Like, is this a 100-year storm? Is this a 500-year storm? Things like that. You can get that through the Extreme Precipitation Monitor. There's the most likely and then reasonable worst case scenarios available on here. The most likely ARI is available on HURREVAC. Basically, you would use this to distinguish between a bad event and a really bad event, right? So this is something that you can use to help ground your expectations for how bad will this be compared to past systems. Last but not least, and this is brand new for this year, the Urban Rain Rate Dashboard. This was unveiled after the last hurricane season. The direct link is also here on the slide. This basically is a fully zoomable and fully interactive page that ingests all of the modeling data that we have and then shows the risk levels for heavy rainfall across all the major cities and metro areas across the country. And so those of you whose jurisdictions include a large city or even a medium-sized city, you might want to refer to this page. And when you click on it and you zoom in, you get a full breakdown of the spread of models, the most likely timing of when the rainfall will happen along this timeline. And then if you look on the drop-down menus in the top right, you could also set exceedance thresholds based off of the ARI, the annual recurrence interval, or the precipitation rate. So if you care more about, is it raining, is the rain going to exceed 2 inches an hour or 3 inches an hour, things like that, you can also set the thresholds according to that and then everything on the dashboard will change and shift according to what you set as the thresholds. So I encourage everyone to explore this page. This is the first hurricane season where the Urban Rain Rate dashboard is available. So we also look forward to hearing your feedback on this, because this is still an experimental product. And with that, I'd be happy to take any questions.
All right, thank you, Owen. And I'm going to bring in another member of our team, Megan Wells. Are there any questions we want to elevate at this time?
John, no outstanding questions at this time.
So thank you for taking the time to be with us today.
Sure thing. Thank you for having me.
All right, and that means it is time to transition to our third presenter of the day, certainly not least, and we're excited. This is our first time in the HURREVAC webinar series, hearing from the National Water Center. So we have Jason Elliott joining us.
Thank you very much. Really appreciative of the opportunity to briefly share with you the latest updates in our flood inundation mapping rollout. I kind of want to start with what might otherwise be the end of this presentation, which is that what you're about to see is not yet available in HURREVAC, but it's information that you may well want to use alongside HURREVAC during an event, or for that matter, even when there's not a tropical cyclone, because it has utility regardless of that type of an event. Before we talk about what's new and how you find it, I kind of want to briefly acknowledge where we've come from. For many years, forecasts from the National Weather Service were just a table of text hydrologically, and that's still available. There are still people who use it in that format. There's nothing wrong with it, 40 years later. But just before the turn of the century, we began putting that table of text into a hydrograph form. And those are still available too. There are still lots of people that use them. We've modernized those hydrographs in the last couple of years into a more dynamic format instead of a static graphic. Still plenty of utility there. But even back when it was just a block of text, it was well realized that what we really need to see is what this means. What does that 13-foot number mean? What does the fact that it's risen 10 feet in the last 6 hours mean? And so early in this century, we started deploying flood inundation maps at a limited number of locations, largely places that had the money to develop and deploy the maps themselves. In the early 2010s, I was involved in the rollout of flood inundation maps for the Washington, D.C. area. That was one of the spots that got them during that time, but the number of places that had them was still relatively small. It was not anywhere near the entire country. But 3 years ago, the National Weather Service began a congressionally mandated rollout of inundation services to the entire country. That rollout will be essentially complete within a few months. It began in 2023 with parts of Texas and the Northeast. It's been expanding from there each year since. And nearly 100% of the US population, essentially everybody except parts of Alaska, American Samoa, and Guam, will have publicly available inundation mapping before October 1st of this year. And that does include parts of Alaska, Hawaii, Puerto Rico, and the US Virgin Islands will have the inundation mapping at that point. And already do, actually, those locations. If you remember nothing else from today's presentation, remember this. All of our available public inundation mapping is at water.noaa.gov through the National Water Prediction Service. Actually, pretty much all of the hydrologic information that we provide is on that site. There are a few things that are in other places, and I'll talk more about that at the end of this presentation. But again, water.noaa.gov gets you to pretty much everything, and there are links there that get to these other things that I'll talk about. There are, as you see here on the graphic, 3 different types of inundation mapping that are available on a real-time basis. And again, this is tropical cyclone or not. First is the analysis inundation, which is our best indication of what should be inundated during the last hour. What it uses is observations of stream flow where we have them, and then information from the National Water Model where we don't. It'll combine those together, develop an inundation, and that'll be the analysis. It updates every hour with the latest information that's available. It's not a forecast. There's no rainfall in it. It's the best approximation of what we believe is occurring based on the modeling and the observations right now. Then there are 2 types of forecast inundation available. The first is available everywhere that you saw on the map on the prior slide, and that is the National Water Model's max forecast inundation. This is updated every 6 hours based on forecast rainfall from the national blend of models. And the mapping represents the maximum flood extent expected during the next 5 days. You see there at the bottom in the last bullet that it does take a while to run because you have to have the entire national blend of models output to run. You have to have all of the other things to come together. So it does take several hours after the model runtime for that output to be available, but it does update every 6 hours regardless. And then the second type of inundation mapping available is based on the forecasts from our National Weather Service River Forecast Centers. The RFCs produce forecasts for thousands of points each day, and what will happen is the modeling takes the forecast from the RFC, their forecast stream flow, places it in the model as though the model came up with it, and then routes that stream flow all the way downstream, and then provides the maximum extent on that particular stream over the next 5 days. All the little streams that come into it won't be there, but that main stream where we're doing the forecast and any other streams that come in where we do a forecast will be shown on that graphic. The plus here is that this updates very quickly. When the River Forecast Center does their forecast, like they are doing today down along the Gulf Coast or up in the Midwest, both places where we have active flooding today, as soon as that forecast comes out, it gets brought into the model, and the updated inundation map should be available within 45 minutes, usually sooner than that, just depending on how quickly it gets picked up and put in. So those are pretty rapidly available. If you're monitoring River Forecast Center forecasts and you see one come in, you can pretty readily go back within 30 or 45 minutes, and that inundation map will be there. So those are the 3 forecast services, but there's also a static service that I want to make you aware of that's available at some locations that can be a great tool for planning. We call it categorical FIM, or CAT-FIM for short. They aren't available everywhere, or even at all of the River Forecast Center's forecast locations, but where they are available is at locations where our hydrologic experts have determined that the inundation map is a reasonable depiction of the expected flooding based on the knowledge that we already have from either past floods or from folks from the Weather Service or the USGS going out and doing field work to determine potential impacts. So these can be considered really good and reviewed depictions of what's expected 5 miles upstream and 5 miles downstream from wherever that gauge location is. Within water.noaa.gov, you're able to change the base map on these CAT-FIMs to actually see what's expected to be inundated at a given threshold or level. And again, because this is static, not tied to a forecast, you can go in and look at 15 feet, 16 feet, 17 feet, and see what's going to be inundated at each of those levels and use that for initial planning purposes when there's not even a flood occurring. So it's a great tool for the toolbox where it's available before an event threatens. And I wanted to note that, obviously a lot of us have our own GIS dashboards or other tools to access data. And again, these are not yet available within HURREVAC. So in addition to water.noaa.gov, if you want to pull this data into your own dashboards, this link that's at the top of this slide will get you there to all of the information. One thing I really want to make sure you are aware of if you do want to use it in this way. You'll see a bunch of directories that you see on the graphic on the left-hand side. The only one, you see one there that says FIM_LIBS. You would think they're all there, and they're not. Only the CAT-FIM information is in that directory. For National Water Model inundation, you'll have to go to the National Water Model NWM directory. And for the RFC inundation maps, you go to the RFC directory. So there's 3 different directories where these things are housed. You have to bring them all together and pick the ones that you want if you're going to bring this into your own dashboards. And then the last website I want to make you aware of is the one on the right of this slide, which is the National Weather Service's National GIS Viewer. This has, in addition to the inundation mapping, also has some additional information from the National Water Model in it. So that's a way to get at some additional material if you really want to deep dive into some of the information and not just look at the inundation. You can go to the National GIS Viewer and see that additional information. Before I close, one additional item. Right now, all of this inundation mapping is freshwater only. With an update to the national water model that's expected for later this summer, the real-time surge output that Cassie mentioned earlier is going to be coupled in with our existing mapping framework during tropical events. And so we expect to be able to begin internally analyzing a total water level version of inundation mapping after that point. And I hope that'll be what I'm able to bring you here for next year's update. So with that, I will close. I'll be available for any questions you may have now, or you can contact me by email at any time. I really appreciate your time today. Thank you very much.
Thank you so much, Jason, for sharing those exciting developments. And once again, I'll bring in Megan to see if we have any questions for Jason at this time.
Yes, we do have a question. What datum and what DEM are the National Water Model inundations based on?
So the DEM that we're using is a 10-meter DEM, so it's actually upscaled in some cases, but we're also now starting to, the dev team here is starting to plug in more high-res DEMs where they're available in specific locations and where we know it's going to improve performance. So it's starting to become a patchwork quilt, where in some places it's using higher res information, but the base is a 10-meter DEM. But then, as I said, things get sort of patchwork quilted in as opportunities arise.
Great, thank you. I have another question of why are the National Weather Service flood advisories arbitrary shaped polygons instead of following basin boundaries?
That's actually a fantastic question. It's unfortunately a software limitation at this point. We're only able to do a certain number of vertices in our polygons, and so that doesn't allow us to necessarily be right on those boundaries. That's something that we've known for a long time, and it is something that's being worked on to make them more precise. But at this point, we're limited in the number of vertices we can have on that, so it makes it where we have to be pretty broad.
Thank you. John, do we have time for one more question?
Yeah, go for it.
Great. One last one. Do you actually run a hydraulic or hydrologic model to generate the inundation mapping, or is it purely dependent on water elevation gauge observations?
It's to an extent, depending on where you are, it's all of the above. Because again, we're sort of trying to get the best we can get out of all of this. So it's another case where the base is one thing, and then when we have hydraulic models, we can plug those into those areas to be able to run through them instead. So there are a number of places across the country where it's now a hydraulic HEC-RAS model that's determining the inundation, but the base for the rest of the country where we don't have those kind of models is a more simplistic model that we call hand height above nearest drainage.
Wonderful, thank you. And for any outstanding questions, we'll continue to answer them in the Q&A. And I will turn it back to you, John.
All right. Thank you, Megan, and thank you, Jason, also to Owen and to Cassie, and also Laura down at the Storm Surge Unit for being so generous with your time today. This is why we're so excited to do this HURREVAC webinar series and be able to put you in touch, not just with the products in HURREVAC, but what they mean and how they get to you. So a reminder, the FIM is available in the NOAA sites. We've put that link in the chat here in GoToWebinar. It's not in HURREVAC, but we wanted to make sure you are aware where to find it and what it means. Next, we will be moving on to our demonstration in HURREVAC. Here are our goals for today. We're going to access the current rainfall and flooding layers from NOAA and the Weather Prediction Center. We're going to map all of the National Hurricane Center's operational storm surge products. We're going to use the SLOSH Explorer, a tool inside HURREVAC, to map worst-case storm surge scenarios. We're going to explore the difference between MOM and MEOW products using the SLOSH Explorer. And we're also going to go back to points of interest again, and we're going to show you how you can interact with surge data using surge flags and points of interest. So I'm moving into my web browser. I'm already logged into HURREVAC.com, but I haven't moved anything around just yet because we're going to do just a little bit of recap. It is not often the case that we have an active Atlantic storm affecting the United States while we are doing our webinars. And we had some interesting developments with this in recent hours that call back to some of the topics we had yesterday. So it's worth pointing out a couple of things. Late this morning, we had the potential tropical cyclone along the Texas coast upgraded to Tropical Storm Arthur. And right now, this is being live on the afternoon of June 17th. If you're watching this as a recording, just know that some of what you're about to see will look a little bit different when you're in HURREVAC. But the latest we have is Advisory 6A. When I go back to show you Advisory 6, notice the timestamp on this. This was at 12:30 p.m. Eastern Time, because my device is in Eastern Time. And if you're in Central Time, you're seeing 11:30 p.m. on Advisory 6. And that indicates that is a special advisory. Robbie mentioned that this can be the case, that the National Hurricane Center can issue one. And so we look in our text advisories window and bring up the forecast discussion. And the forecaster here has noted this special advisory is being issued to extend the tropical storm warning southward to Sargent, Texas. So the forecast discussion is always a great place to go to understand so many things about the forecast, but also the context here when we have something like this special advisory. And at that time, there was also a tropical cyclone update product issued by the NHC that was showing up in the top right corner of the HURREVAC workspace as a notification. So I might as well keep this track on the map because I'm going to start by demonstrating some of the conditions tab layers. The conditions tab layers, as we've mentioned a few times this week, in the top left corner, these are all live weather forecast information or analyses or outlooks that are current as of today, June 17th, 2026. And so these are going to be updating usually at different times throughout the course of the day. I'll try to, as I go through them, explain what those update cycles are like, but it's going to be a pretty fast tour. And if you ever want more detailed information about these products, you can of course review this webinar or go to our HURREVAC user guide. In the lower right corner of the workspace, there's that question mark that opens the user guide in a new tab, and it's searchable. And that is our up-to-date documentation about all the products that are in the program. I'll leave that open because we might come back to it later on. And just one more note as I'm doing this demonstration for you, as you try to follow my mouse around, I will try to emphasize areas I'm highlighting or clicking on by using a circle highlight in my workspace. And so right now I'm doing that little circle highlight around New Orleans. And so be on the lookout for that if you're trying to watch my screen and follow along with the mouse pointer. All right, so we're going to move through a pretty quick tour of our layers in the conditions tab that pertain to rainfall and inland flooding. And we heard a lot about that in our WPC presentation. We do have, of course, radar and satellite, as we saw on Monday's demonstration. And moving on down to the fourth item in this list, this is a menu, and I'll click this plus to expand. This is forecast rain. This comes to us from the Weather Prediction Center, and there's several time intervals you can choose from. I'll show you what cumulative days 1 through 3 looks like. The legend on the bottom shows you what these colors mean, but also, as I hold the mouse pointer over the map, I have a small tooltip. So I'm in this area in Alabama that is in the orange color, and it says 5 to 7 inches. And so that tooltip reflects what's in the label, and that's a new thing we added within the last year. Notice that as I do have this colorful data covering the base map, one thing I can do to make it easier to see my states is to go to the Resources tab and turn on my state and county boundaries. I think I'll leave that on for the rest of today's demonstration. You can only look at one of these forecast rain intervals at a time. Also, something new that we've added in recent months, as Owen mentioned, is some of the layers from the Extreme Precipitation Monitor. In particular, there's 4 using the average recurrence interval, or ARI, for different time periods. I'll show you what it looks like here with the day 1 through 3 or 72-hour period. And zoom into this portion of southern Alabama so you can see that these shaded regions on the map correspond to these colors here in the legend, with one value there in Pike County going over the 5-year ARI. We've put a link to the complete suite of extreme precipitation monitor output. It's right at the bottom of this folder called More Product Info from WPC. And you click on that, it opens a new tab, and this has all of the options. It has the downloadable outputs. It also has the documentation. So we encourage you to spend some time with that. Turning any layer off in the conditions tab is a matter of just clicking that radio button again or unchecking it. I'm moving on down to the observed rain folder. There's several options in here. This does have a different color table from what we just saw with the forecast rain layer, but this also comes to us from NOAA's map services. And there's a couple of options here. There's last 12 hours and last 24 hours. These first two, last 12 hours and last 24 hours, these update on an hourly basis. There's some others that go through the last 2, 3, 4, 5 day period. Those update daily, first thing in the morning Eastern time. As we talk about how you can interact with this and use HURREVAC to do your storytelling, one thing you could do with this type of data layer is use the clipping tool to isolate a particular state or just the land areas in the United States. So in our toolbar on the right side, a little ways down from the top, what looks like the scissors, this is our clip layers tool. And I've got the observed rain selected as my input layer, and I can make the United States the overlay. And when I click clip, that excludes everything offshore and just shows the observed data in the last 24 hours over land areas in the US. Also note what happens is that HURREVAC displays things in the order that you turn them on. So I turned on my state and county boundaries and then went to turn on this observed rain. So it's actually showing up over these state lines. If I want to move the state lines back to the top, here's how you do it. Quick layers. I'm in the toolbar back on the left side of the tracking map, third from the bottom. It looks like the 3 squares layered on each other. And this is where I can control the opacity of the observed rain by going into this row and dragging this slider back and forth. You can see how I can make some customizations there. And I can also use the arrow in the header, once I've selected a row, to move the selected layer down in the display order. So now observed rain will go back below my state and county labels. And I could even make those state and county labels darker by sliding that opacity up to 100%. So that's a little bit of the customization you can do. I'll close out of quick layers, and I'm also going to turn off that observed rain and keep working my way down. The excessive rainfall outlook is that situational awareness about the flash flooding hazards over the next 5 days. We do have several layers in here. There's the day 1 period, and check the legend at the bottom to see what the valid time period for that is. So this is the period ending 8 a.m. on Thursday, June 18th, in Eastern time, that is. This is available year-round regardless of whether there is a tropical cyclone that we are tracking. When you are dealing with a multi-day situation, this is where the cumulative days 1 through 3 option may be useful to you because it just stitches together the highest values from day 1, day 2, and day 3. This is also a little bit interactive in that when you hold the mouse pointer over a particular area, like this red area between Louisiana and Southwest Georgia, that shows moderate in the tooltip. Moving down into, we saw wind yesterday, we're going to look at rivers and tides. And this does bring in some information from the National Water Prediction Service, especially when it comes to these river gauge pages. There's forecast water level and observed water level. I turn on forecast water level. These look like squares. Observed water level looks like small circles. And the legend at the bottom is showing me that the colors go from green for no flooding all the way up to purple, indicating major flooding. A new feature that we want to make sure you know about is that you can now filter out the gauges that are not in flooding. So it makes all the green circles go away. I just click this checkbox below that folder, and now I've just isolated the gauges where the observed water level is at least near flood stage or above. And I'll zoom in a little bit closer into southern Mississippi and the Pearl River area. And you notice as I hold the pointer over any one of these dots, there's a little readout of what the recent observation is and in comparison to the flood stage. And scrolling back toward southeastern Texas, let's look at Dickinson Bayou. This is actually interactive. So if I click on that red dot there, that opens a new tab in my browser. It goes directly to this gauge page from the National Water Prediction Service. And this shows a time series of what's been observed. And as I scroll down, there's a whole lot of other information here about the local datums and thresholds and some of the local impacts. And these are all different depending on where you click. Notice that between the observed water level and the forecast water level option under river gauges, there's slightly fewer and they're slightly different places. Not every gauge has a forecast extending over the next few days, but I can certainly find some here into Western Louisiana. Clicking on that square also has the same behavior. It opens a new tab, and this time series now shows the observed as well as the forecast line in the purple there. So we encourage you to spend some time with that. At the bottom of this folder is a checkbox called Tide Stations. And this is another way you can reference some information beyond what's displayed here in HURREVAC. There are triangles, blue triangles, and you see the name of it as I hold the pointer over it. So the Galveston Railroad Bridge there, if I click on that, I click and get a new tab for NOAA's Tides and Currents page. And this gives me something kind of similar to those river gauges, except there's a whole wealth of information here about the datums and the historical conditions at that particular tide gauge. So that is some a way for you to exit HURREVAC to get some more information about tide conditions. And the very last one in this folder, this is the national forecast chart. This is just a snapshot of the day one fronts and precipitation. And really, this is a more national level view of what's going on with the bigger weather picture. So if part of your storytelling, creating a graphic or a sit rep, is not just to show where our tropical storm is, but where it is in relation to fronts and other active weather across the United States, this may be something that is of use to you. And that rounds out our conditions layers. Again, these are always going to show you what is the latest. These do not correspond to an archive storm. So when we go to look at our operational storm surge tools, we are going to be looking at an archive situation. If I turn on these conditions layers, they are not going to match that archived storm. All right, and with that, transition to the topic of storm surge. It's time for our first poll question of the day, just a little get to know you and your area of responsibility. Is your location that you're in right now or your area of responsibility for your work potentially at risk of storm surge inundation? Is it yes, is it no, or do you not know? All right, let's take a look at what you said. A lot of activity here, and 60% of you saying you are at risk of storm surge inundation or your area of responsibility is. A third of you saying no, and also some of you don't know. And what we're here to do today is help you find out how you can make that assessment using the tools in HURREVAC. So for those of you who said no, of course, still, if you're responsible for areas that are farther inland where there is that risk of heavy rainfall and flooding from hurricanes, we hope that you find those tools in the conditions tab useful. So let's close out of that poll and come back to our demonstration. I still have my active storm selected as the current one, Tropical Storm Arthur. That's not what I'm going to be using for the rest of my demonstrations today. So to remove it from the map, I'm going to click the checkbox next to that name and it clears off. In fact, we're going to pick up where we left off with our demonstrations the past couple of days and continue to look at Hurricane Milton from 2024. And I've typed in the name and clicked the checkbox next to it, and it loads on the map to the very end of the storm at Advisory 23. Remember, I want to move back to an earlier point in time so that we can go through it chronologically. And I want to start us at Advisory 4 by making this selection from the list at the top. And at this time, we had a tropical storm and a forecast track that was aimed at the Florida Peninsula. And the hazard was in about the day 4 period of this forecast. So what do we know about the storm surge hazard at this time? I'm actually going to start us with the text advisories. And let's take a look and see if we have any storm surge watches or warnings in effect yet. By reading this summary of the watches and warnings in the public advisory, I do see tropical storm watches in effect for parts of Mexico, but storm surge products come along when there are storm surge watches and warnings for the United States. And we see here those watches will likely be required for portions of Florida later in that day. Sunday, October 6th. So if I go to turn on any of the storm tools in HURREVAC that pertain to storm surge, I'm not going to see any data. For example, we saw the wind watches and warnings. We get to it from this hurricane flag icon. Also in this folder at the bottom is the surge watches and warnings. And I go to turn that on, nothing showing up. Or if I go to turn on the potential storm surge flooding, I get a little notification that says no potential storm surge flooding layer exists for Milton Advisory 4. So I'm just going to turn that off. Let's move forward to Advisory 8. I can do that with my right keyboard arrows or by clicking or selecting from the list. Let's see what's going on in our text advisory. This is the advisory where a storm surge watch was first issued for the Florida Gulf Coast. So let's see what these NHC operational products look like at that point in time. When I say operational, it means it's linked to an advisory that is coming out from an active system. So in the watches and warnings tool, I'm looking at the surge watches and warnings layer and zooming in a little bit, and I see this lavender color covering much of that western or Gulf Coast of Florida. And that's an indication to me that if I continue to go down and look at these other tools, I should be seeing some data. And indeed, the peak surge graphic, this is what we're going to talk about next. We heard a good explanation of that, but I want to show you in HURREVAC that you have two options here. There's with and without surge communication points. What does that mean? The surge communication point is this black dot that separates these stretches along the coast. You see here one in the middle of your screen at Bonita Beach. And as I move up farther, there's spaced every few counties you see here. That may be useful to the graphic I'm trying to make or show. If it's not, you can do a version of this where it takes those labels and black dots off. And a reminder that this is more of an overview as we're looking at the regional or state level. It doesn't tell us a lot about doesn't tell us anything about neighborhood level or within communities how this might vary. So turning off a layer from the Storms tab, when it comes out of a menu like this, I just go into that menu again and click, and that will clear it off the map. Next, we look at what we call potential storm surge flooding. This is the icon that looks like the blue waves. And there's two options in here. There's with and without the tidal mask. The tidal mask covers up the areas that are routinely wet at high tide. So to see more color on this map, just to kind of illustrate what this looks like, we're going to start without the tidal mask. And you may already start to notice some colors along the coast, but as I zoom in a little bit closer, it becomes easier to make out. And I'm coming into the areas of Charlotte and Lee County here. The legend at the bottom, as we saw in the presentation, tells us that we have these bins of 1 to 3 feet in blue, greater than 3 feet in yellow, on up to greater than 9 feet in the red. In areas where there are levees or flood protection systems, you may see that it is hatched out. That's not the case in this location. This is in feet above ground level, and the legend reminds us that as well, and there's even a timestamp on that as well. This may be the kind of data that you want to look at with a different base map. Really depends on what you're trying to do and what looks good on your screen, but you might find that the light gray canvas is useful with this kind of data. So I'm opening my base maps from the lower right corner. The light gray canvas is just grayscale. So that means any color you're seeing on the map is color from the data, not color from the map base. And so that can be useful for drawing your eyes to problem areas. Some other things you can do to adjust this display inside HURREVAC to make it easier to work with is going back into quick layers and sliding that opacity higher or lower depending on what you're trying to do. This might also be the kind of map layer that you want to see the imagery to understand what that land use is like. And so if I turn on the imagery base map and zoom in even closer to this neighborhood level, this is the level at which we can make out neighborhoods and subdivisions and roads. I might go back and forth on my opacity here. And keep this in mind if you're joining us again tomorrow, which I hope you do, and we start looking at which evacuation zones are potentially affected by the inundation hazard, we're going to be using this kind of approach to help us see how the two data layers intersect. This isn't the only way I can interact with it in HURREVAC. I can also right-click and place a flag to label these points. And I do want to be somewhat zoomed in when I click so that I know I'm clicking precisely in an area. If I'm out on the state or the national view and just right-click, I'm not really sure which pixel I'm hitting. You can see just how dense or how high resolution this is. But I know if I click toward the middle in this yellow area and place my surge flag, if that was a piece of infrastructure, a facility, an intersection that was important to my operations, I can annotate the map by right-clicking, and this little label here says greater than 3 feet in that pink flag. And perhaps there's another area up here to the north in that blue zone, and I place a surge flag there that's greater than 1 foot. Remember, this is not a footprint. This is a reasonable worst-case scenario based on probabilities. And so if I'm zooming in and out and looking at several locations up and down the coast, this is why, again, I want to get a little bit of a closer look when I go to make those selections, because fairly zoomed out, I might click a pixel that turns out to be a part of a creek or something like that. So it's worth zooming in a little bit to get the feel for this. Another important thing to emphasize as we are looking at this, potential storm surge flooding. This is available up to 72 hours before impact. And when should you check for it? After the advisory comes out, about 60 to 90 minutes. So right now we're looking at advisory 8, which is 5 a.m. on Monday, October 7th. If you were to come into HURREVAC right at 5 a.m., you would not see this layer. You would see that notification in the top right that says potential storm surge flooding not available. That means if you know it's on the way, you would want, as part of your rhythm of checking for the latest in HURREVAC, to come back. In this case, it would be in Eastern time, 6 a.m. to 6:30 a.m. because, as we heard, the process for making this graphic kicks off once the public advisory comes out. And then the modeling happens, and then it has to get processed and verified and put on the servers, and then it's ingested into HURREVAC, and you can interact with it here. So this is not going to be available right when all the rest of the forecast updates are. It's worth coming back into HURREVAC, again, 60 to 90 minutes, and checking for the latest. How often is this updated? Every 6 hours. So if we go to an intermediate advisory, which let me jump forward in time here to, we're looking at 14 and 14A, we're seeing the same data. But moving ahead to advisory 15, that's when we see the new colors on the map. And the final thing I'll do is show you what this looks like with the tidal mask on. And notice in this area, a large swath of gray appears in what was previously red. If I right-click in there, the surge flag says ITZ, that stands for intertidal zone. And so that tidal mask is a filter that can draw your eyes to areas that are normally dry that may be affected by storm surge. Another thing to be careful of too, as we place storm surge flags, is if you were to right-click in an area that's outside of the data, you can see where it says less than 1 foot. That does not mean that there's not some vulnerability from freshwater flooding or riverine flooding. So be aware of that. And usually, as I mentioned, when this product starts to come out within 72 hours before the hazard arrives, we know from looking at this example that advisory 8 was the first in this sequence in Hurricane Milton that brought the potential storm surge flooding map to the United States. That tends to be a point in time where we will put out a notification to let you know that that data layer is now available to you and something that you'll want to be checking if you're in the affected area. There, already some questions about downloading. This is not a layer that you can download directly from HURREVAC, but if you are a GIS user, those files are on hurricanes.gov. So this is not the last we're going to see of our surge flags today. These, if you were with us yesterday and saw our wind flags, surge flags are kind of the same. You can just place them as you need them, kind of spontaneously. And if you want to make them go away, you would right-click again. And the middle section here, it's all about surge products. You would click Remove Surge Flags. and you can remove the nearest one to that clicking point, or you can remove them all. Or if you've gone to the trouble of clicking and placing flags in areas that are important to you, and you don't want to repeat that every time you log into HURREVAC, you can save your surge flags as points of interest. And so in this middle option where it says place surge flags, in the submenu, it says save surge flags as POIs. And at first it's going to kind of confirm that for you by showing a little blue dot and coordinates. Let's go into my points of interest list to show you what these look like. Click on the map marker icon about halfway down the right and go to my points of interest list. And by default, it just names them based on the coordinates. You can go in here and edit these and give it a more descriptive name if you want to. But the type is saved as surge flag compared to those other types that we saw in previous days. And just turning on the point of interest, that blue dot doesn't bring up the label, but it is saved in your user profile. So let me just pretend like we have closed out of HURREVAC for the day, logged out. We've logged back in tomorrow. Now we are up to advisory 18. And I would load potential storm surge flooding on the map. Now, I didn't actually log out, so it remembered that my flags are there, but if I hadn't, I would place surge flags and then click load POI surge flags, and that will automatically populate these 4 flags in the areas that we had them yesterday. And instead of doing 4 clicks, you are only doing 1 click. So we hope that's a time saver for you. Notice how the forecast has evolved since 24 hours ago. We, again, are seeing more dry values in some of those areas. It doesn't mean that it's not going to be heavy rain and flash flooding, but the storm surge component and the reasonable worst case scenario from that looks like it has evolved with that forecast. So again, pretty useful tool. And once that's available to you, it is something that is worth checking out here in HURREVAC. But there are layers you can use to evaluate storm surge risk year-round, regardless of whether there's an active storm. And that's where we get into the Storm Surge SLOSH Explorer. Before I do that, we've covered a lot of these operational products. I'm just going to pause and check in with our Q&A team and check in with Megan and see if there's anything that we want an answer for or any demonstrations we need to see again.
Yeah, thanks, John. Could you go over one more time the quick layers functionality?
Yeah, absolutely. Quick layers is what we use to control opacity and layer. So this is a button that is on the left side of the map, third from the bottom, and I'm circling it right now. There's 3 squares stacked on top of each other. And if I wanted to take the potential storm surge data and make it less opaque or more opaque so I could see more of the underlying base map, this is where I can slide that back and forth. And if I wanted to move this on top of or below some other data layer, I would highlight that row and then click this arrow to move it up or below in the display order. But that's not really going to do too much right now because I don't have a lot of other colorful data on the map.
Great, thank you. I think that's good for the Q&A portion right now. Thanks.
All right, so that means we are ready to move into our SLOSH Explorer phase of the demo. And I'll show you what it looks like when I restart HURREVAC. And it's gone back to show me the active tropical weather outlook and the active Atlantic storm. In this case, we have Tropical Storm Arthur. I'm going to uncheck this box. I'm going to uncheck the tropical weather outlook in the toolbox, and I kind of have a blank slate again. So we could sort of put ourselves in the mindset of, maybe we are in a planning role. Maybe it's not hurricane season. Maybe it's January or March, and our job is just to understand what is the worst case scenario for the facilities that we're interested in or the infrastructure. This is where we can use those SLOSH moms and meows we heard about and interact with them in HURREVAC. This is our 4th storm tool in the toolbox at lower left. When I click on Storm Surge here, it opens a panel from the right side. This is what we mean when we say the SLOSH Explorer. Quick word about what's going on in here. The top section of it, this is where we interact with moms and meows, and we're going to step through all of that. The lower section, which I'll get to at the end of the hour, is about hindcasts or modeling of past storms. Top right corner of this is a link to the user guide page all about the SLOSH Explorer. And this shows us that graphic, once again, of what you can be looking at in various timeframes. Within 72 hours, certainly within 48 hours, when we have the operational advisory products from an active situation that is moving our way, that is going to be the most specific information to look at about the hazard. But when we're a little farther out, or even beyond 120 hours and just doing year-round planning, we can understand something about a worst-case scenario by looking at meows and moms. While I'm on this page, I'm going to scroll to the bottom. Again, for those of you who are GIS users and are interested, this tells you how to export the data and what it means. I'm not going to do a demonstration of that right now. And also, I would not encourage you to make any downloads right now because these tend to be large files. And if you do that, it might use all your bandwidth for that instead of for watching this webinar. And so in order to keep your webinar looking good, maybe this is something you can research and explore in your own time later on. But that's where you go to learn more about getting SLOSH data out of HURREVAC to use in other GIS programs. And now I'm going to start doing a lot of detailed clicking around. So if you are a first-time HURREVAC user, my recommendation would be to just go ahead and watch my screen instead of clicking back and forth to your screen, and then practice later on, or use the recording later on to practice side by side. But we don't want anybody to get lost. And because of our limited time today, I will have to move a little bit faster just to make sure that we cover these topics. So hopefully, you can have plenty of time to investigate this on your own. Question earlier about base locations. Yesterday, I had set a base location in Florida because we were using the example of Hurricane Milton. Let me show you what it looks like to set a new base location. I'm going to go to New York City to talk about examples for moms and meows. And I'm going to right click in Manhattan and set base location here. And it shows up in my user preferences and there's a little flag on the map. Can you make a base location go away? No, it is stored in your user profile. You can make this little flag go away by clicking this checkbox in the column called display in the row called coordinates. Notice the base location is still there. You just don't have the flag on the map. If base location is not relevant to you, just ignore it. If you're state level or national level, if you do want it somewhere in a state that you care about, that's a good way to filter down reports quickly. But it's only meant to be a shortcut for you. So if it's not useful to you at all, just disregard it. Also, points of interest. We click that checkbox to turn them on and off the map, but my points of interest are still there even after I refresh the program, albeit they're in a different state. But they don't show up when you log into HURREVAC again. To turn them back on or to delete them from your list, go back to this points of interest list right here. So I'm going to click this header, this checkbox, and just click delete selection, and then all those surge flags go away. All right, so let's see what these surge maps look like for moms and meows in the New York City area. Remember, moms stand for maximum of maximums. And so it's a composite of all basins up and down the coast of the US, and it takes into account every scenario for a given category. So the only selection we have to make to turn a mom layer on the map is a category. And I'm going to start by choosing category 4. And then this button is active, so I can click display on map. And now HURREVAC has zoomed out to remind me that this is a national level composite. Certainly no single storm is going to do all of this inundation. To quickly go back to the area I was just at, here's a shortcut. In the top right corner in the map tools bar, there's an arrow that points to the left called go to previous map extent. That's how you can quickly hop back to that map view you just had without a lot of scrolling. So we hope that's a useful shortcut for you. The tropical storm mom, that is not available because that's grayed out. Also a word about the category 5 mom, that only goes up to the North Carolina-Virginia border, because based on hurricane history, the risk for category 5s is from that point south. So here I have a different look, a different color scale than what we saw in those operational products. The legend at the bottom shows me this goes from 1 foot in blue to greater than 10 feet in red. We can actually have point values all the way up to 21 feet. And so the way you can figure that out is with right-clicking and placing surge flags. This is also interpreted as inundation above ground in feet. So it's as if you are standing in that point and holding a yardstick or holding some measurement device above the ground on that point on the map. So this takes that elevation into account. There are some parts of the country where the data is hatched because it's a levied area. So be aware of that. And because I refreshed my browser, this has gone back to my default base map. If I want to return to the grayscale base map, I have to make that selection again from the base maps in the lower right corner. So let me give a refresher again on how we find some specific locations. If I am trying to look up a facility of mine and I have the addresses, one thing I could do is just zoom in on the map if I know where it is. But if I want to quickly go there, I would look up geocode location. And that is from this same tool that got us to the points of interest list, about midway down the right side. Geocode location is also good for looking up landmarks. So for example, I could type in LaGuardia Airport. And it would help if I spelled correctly. And then click search. And it's zoomed me in on the map to where LaGuardia is. Of course, it's bigger than a single point on the map. And so think about that as you place surge flags or make points of interest surge flags. If you're dealing with something that's many, many acres, the value you see on those flags could vary depending on where you choose to click on this depiction. This is the category 4 map. If I move down to and want to see what this looks like for a lower category, like category 2, I would make that selection in the panel on the right, but I have to click update for the map itself to change. And see how there's less extent and in most areas, smaller values indicated by those colors as category 2, still significant threat in this particular area, but not quite as high as the category 4. So I'll just pick an arbitrary spot here along this runway and right click and create a point of interest called LGA. And again, you don't have to do this. This is probably a good time to just watch my screen and see how I do it. And I could designate this right off the bat as a surge flag type of point of interest and click add. And there I have a label showing 19 feet at that particular coordinate. Or I could come over here on the other side and right click again and create point of interest, call it LGA2. And click surge flag and click add. And in that particular spot on the map, that is 9 feet. And let me pick out a few more spots in the greater New York area so that we can see some comparisons as we investigate some other data layers. I'm going to come down to Breezy Point in southern part of the Queens, south of JFK, and create another point of interest there. And call that a surge flag. If I was doing this because I'm really interested in a particular road or building, I would probably want to be more zoomed in. But this is for the purpose of demonstration. That's a 14-foot there. And just so you see it one more time, I'm going to do a geocode location search because I want to look up the Staten Island ferry terminal in Staten Island. And it happens to take me right into that location. To make this little bubble of the preview text go away, I would just click anywhere else on the map and that clears it out. So let me, again, you see the resolution of this. It's pretty fine. I'll click somewhere in these ramps, create another point of interest called ferry, and call this a surge flag 2. And that's 11 feet. So I've got a little bit of variety of locations around the area. And we're going to continue interacting with this as we move into meows. Meows standing for maximum envelope of water. And that is the second radio button in this interface. Here's where base location can be a shortcut for you. It already knows that I want to see meow data for the northeastern slosh basin. Now, what's still showing up on the map is the MOM. It might be helpful if I just remove this from the map so you can kind of see this from start to finish. Remember, a slosh basin is a region along the coast, kind of delineated, can usually cover one or multiple states. And the name for the slosh basin that is valid for this New York area is called the Northeastern Basin. So each slosh basin you look at, I can explore different ones in this list here. They all have different characteristics based on what that hurricane history and climatology is like. So if I look here, there's not an option to go up to category 5. But if I look at the slosh basin for Texas, here I have options all the way up to category 5 and different directions and forward speeds. In fact, there's slosh basins for Puerto Rico, U.S. Virgin Islands, Southern California. Here's what Southern California's looks like. Also Guam and American Samoa. The Guam slosh basin there. So instead of having to click through this list by designating the base location, it already knew I wanted the data for the northeastern slosh basin. To get data on the map, I have to make 3 selections. I have to choose a category, I have to choose a direction or multiple directions, and I have to choose a forward speed of the storm. I'm going to start by choosing a category, and let's go with category 3. Direction, maybe I'm conducting an exercise or wanting to perform some analysis on hurricanes that were moving due north. I can certainly do that, or I can blend multiple directions to kind of cover my bases if we're talking about a situation where there's uncertainty about that angle of approach along the coast. So maybe I want to take into account tracks that are going to the north-northwest or northwest. That parallel option here implies a track that is along the coast but doesn't make landfall. And then at the bottom, I choose 1 forward speed. I'll choose 20 miles an hour just to get us started, and then I'll click display on the map. And it's zoomed out to a somewhat wider view to show us that this is still a composite of a lot of different areas and potential hurricane landfall locations up and down the coast. No single storm is going to do this inundation. We have to zoom back in to see it for the most part. So I'm going to use that same shortcut called Go to Previous Map Extent by clicking to the left arrow button. And now I'm right back in that view of New York City. And my surge flags are still there from before, and now their values have updated. For those coordinates, there's some version of a category 3 hurricane moving at 20 miles per hour to either the north, northwest, or northwest that could cause water, 7 feet above ground level for the ferry dock, for 9 feet at this spot near Breezy Point, 6 feet to 16 feet there in LaGuardia. HURREVAC is not doing this modeling. It comes to us from the storm surge unit, and you are interacting with it. And so the more selections you make here, it might take a little bit longer to merge those and bring that back into your workspace. This is, again, another case where adjusting your base map or using the quick layers to play with the visibility so it stands out to you on your screen can be useful. And while I do that, I will bring in Megan once again to see, because we've done a lot of clicking around, is there anything that we need to see demonstrated again or any questions that would be good to address at this time?
Yes, could you take a moment to review the difference between the potential flooding with and without tidal mask layers?
Yes, so that is something that comes along, the potential storm surge flooding, this button right here, this is a storm tool. And so if I try to turn this on right now, I don't have a storm selected, and so I'm not going to see any data loaded on the map. That pertains to a particular storm advisory. And the difference between with and without tidal mask is that it filters out areas that are wet at high tide. I'm over here in the SLOSH Explorer with my data on the map right now. That doesn't have a corresponding tidal mask for the map. But again, to really get into the particulars of that documentation, we can go into the HURREVAC user guide and go to my directory of pages and go to the storm surge and inland flooding section and click on the page for potential storm surge flooding. And here's a really good example of what with and without tidal mask looks like with Hurricane Ida in Louisiana. And you see, of course, a lot of wetlands in that part of the country and a lot of areas covered up by gray. So there's expected to be inundation, but inundation over areas that are often wet. So the point of doing so is that it draws your eye to those areas that have color that are usually dry, but expected or have a chance of having inundation. Because again, this is not a literal footprint, but a reasonable worst case scenario. So good question there. The meows and the moms are not tied to a particular storm. This is still a lot of different hurricanes merged together into one graphic. So this is taking into account landfall points all up and down this part of the coast. So when we get this value, we don't know which landfall point it is that gave us that. But that's just it, is that when we're 3, 4, 5 days out from a hurricane, we still don't know exactly where that eye is going to come ashore. And so we want to be planning based on the possibility that, that is taken into account if it does end up being a worst case for our area. If I go to choose a different selection of the meows, again, I could just isolate a particular direction on the map, like northeast at 40 miles an hour, and click update and see what that does to things. So we know that, especially in a part of the coast with a complicated geography like this, that angle of approach and landfall point can make a big difference on which kind of storm creates the worst case scenario for a particular area. And also when I'm making surge flags here, like I go down to category 1, I'm sure some of these are going to start to say dry, like around LaGuardia. Again, this is just focused on the contribution from storm surge. Just because it says dry does not mean that there's not any risk associated from inland freshwater flooding or river flooding. So be aware of what dry means when you're using those surge flags. There's a companion to this that unfortunately we don't have time to demonstrate for you today, but it's called the Surge Viewer, and you get to it from a right click, and it's also in this middle section for all of our surge tools. And this creates a bar chart that shows a distribution of surge heights depending on direction of storm. So it's using this underlying map data, and I'll show you what it looks like in the user guide. And it gives you something like this that you can also interact with. So if you're just concerned with particular coordinates, you can filter in and out categories and forward speeds to understand what is the direction that creates your worst case scenario at that point. So this is how I could quickly say, if this is my facility, if this is my point, and I'm creating an exercise that plans for the worst case, I want to build an exercise where that hurricane is moving to the northeast. That's the very, very short version of it. And we hope you can use the user guide to read through and understand that, if that'll be something that'll be useful to you. I want to make sure we have a little bit of time to talk about what remains in the SLOSH Explorer on the right, and that is hindcasts. So let me remove these meows from the map by clicking that button. And my points of interest are still there as points. The flags have gone away, but I'll also move these points off the map. And just go back to this mom selection so it's a little easier to see this hindcast section higher up in the workspace. So there's a list here of storms that have gone through and impacted the US over the past 6 years. And this goes all the way back to 2020. Let me show you an example from Hurricane Laura in 2020. When I click display on map, this tells me a hindcast is a SLOSH model run that the National Hurricane Center Storm Surge Unit does immediately after a hurricane landfall, usually within hours, certainly within the day, that uses the best track and some limited real-time observations to estimate what the surge was like. It's not intended for public distribution. It is only for emergency management use. Now that data is loading in Louisiana, where it made landfall. So I'm moving out of the New York area and quickly zooming in to show you what a hindcast layer looks like. It's the same color scale as those moms and meows, blue up to red. I can also right click and place surge flags on it. And again, this is something that can be used in response and recovery phase right after a landfall. And we hope that it's not ever going to be the case, but if there is a landfall that occurs and then the Storm Surge Unit has made a hindcast, we will let you know that is available in HURREVAC using a notification that will pop up in the top right to let you know that the hindcast has just been published and that you can make use of it. And that takes us through everything I had for you today. Let me go back and remind you where we are going tomorrow. So tomorrow's about evacuation timing features. The wind forecast tells us when we need to complete our protective actions. The storm surge forecast tells us where we need to complete our protective actions. Both of those are put together along with information from the hurricane evacuation studies, and we're going to explore it, and we're going to go through a lot more examples tomorrow on Thursday, June 18th. And we hope you have a great rest of your Wednesday.